Hi, everyone. Thank you for joining our first webinar of 2021, Refactoring with IntelliJ the Easy Way, with Corina Pip. Before she starts, I want to introduce our expert speaker. So between her work as senior test automation engineer at Sage and her own personal testing projects, I'm very, very happy Corina found the time to do this session with us. So here are 5 things about our speaker that you probably don't know. First of all, Corina is a certified Scrum Master and is an expert in test automation and agile testing methodologies and techniques. 2, Corina is a savvy coder, you're going to see that today, and an experienced programmer, fluent in many programming languages, tools, systems, and platforms. 3, she's an amateur cartoonist. On her blog, I'm a Little Tester, you have the link right there. You can find her testing experiences literally drawn out, as well as blog posts about QA testing and automation. Number 4, Corina lives in beautiful Romania. Totally try to visit there once COVID is over and we can travel again. And 5, Corina is a Test Automation University instructor. Her course on IntelliJ for testers is live now, so be sure to check that out after this session. So without any further ado, I will turn this now over to our expert speaker, Corina Pip.
Hi, hello, how are you? Thank you for joining us for today's webinar. I'm really happy to be doing this today with you. As Adi mentioned, yes, we do have a course on IntelliJ on the Test Automation University platform. And this webinar is going to add some extra information on top of that. Basically, today I'm going to be addressing the topic of refactoring. I have a few slides where we will go over some concepts regarding refactoring. We'll see what it is, why we need to do it, and I'm going to show you how to use IntelliJ to perform some refactoring tasks. I will have some examples. Of course, these are some things you might find in your own work, so they might reflect something you might have been doing already. Just stay tuned to see what goodies we have when it comes to IntelliJ. And I will just kick off this webinar with a little bit of discussion regarding refactoring. And of course, I would have to start with, saying what is refactoring and why do we need to address this. So as test automation engineers, we either use tools or we use programming languages. When we use programming languages, we do write a lot of code. Sometimes our code is excellent, but sometimes it is not that great. The purpose of refactoring is to change an existing code so that it is better than the previous version that we had, but it still performs the exact same task as the code we have just changed. So we're just trying to get to the same result. We're trying to test the same things, but we want to do it in a better manner than was initially written. And we will see what this might mean. First, we should ask ourselves, why do we want to do refactoring? Why, once we wrote some code that is testing some tasks that we need, why would we want to change that existing code? And the answer is always because we want more quality in our work. We don't only want quality when it comes to the software we are delivering to the customers, but we also want quality in our own work. So in our software, basically in the code that we are writing to test what we are releasing to the customers. So quality should always be what we as testers are striving for. Sometimes our code is not following good practices. Because we are not, so when we're using a certain programming languages, we don't necessarily spend time to read what would be a good way of writing the code. We just know of a certain way of writing it, and that's what we are going to apply without reading more or understanding more about how that programming language actually works. Sometimes we need to do refactoring simply because the code performance is bad. And code performance can be one of many things. The performance might actually mean that, for example, when we are running the tests, we are consuming a lot of resources of the machine where we are running the tests. Specifically, we can affect the performance of the machine where we are running the tests because we are using all the memory of that specific machine for only our tests, which means no other tests can run during that time. Performance can also mean that the test takes way too long to run, when in reality, if we would update it and make it better, it would run way faster. So performance can mean a larger number of things. We should also do refactoring when we have unused code. So maybe at one point we created some helper methods or even some tests, and we don't need those anymore. There is no point in keeping unused code in our project, because the more we have code, the more the project is heavy. So let's say that we have a lot of unused files. That means that whenever we are trying to synchronize with a repository, the process of synchronizing, like a Git or SVN or Perforce or whatever you're using, the process of synchronization can become really, really slow as we add more and more and more files to the project. So unused code should not be there. The less code we have in our project, the more efficient we are. The next question we should ask ourselves is, when can we do refactoring? So when can we change a code that is supposed to perform a task? The first point or the first moment when we can change the code is when we are writing it. So let's say we started testing a feature and we wrote some tests for that feature. Before we even get to the code review phase, before we even show our code to somebody else, or before we commit the code we are working on, we can actually change it ourselves. Because sometimes today we write the code, we run it, we analyze the performance, we see how it behaves, and then the next day when we come into the office, we might realize, okay, there is an improvement we can actually do for these tests, and there's nothing stopping us from implementing a better version of it. Our goal, as I said, is to have the best version of the code possible. Therefore, this would be an excellent time to address any issues we might ourselves uncover when we are writing our own tests. And that's not a problem. That's not a problem if we need to change a code which we wrote. It's not shameful, it's not a problem, it just takes a little bit more time, because we have spent time creating some code, but then we drew the conclusion that it's not the right approach, it's not the best code we can write. And that's a lesson that we learned, and we know that in the future, when we are addressing something similar, we can just write the code in a different fashion than what we tried in the first place. A second point in time where we can refactor the code is at code review time. So whenever we are writing our code, we want it to go through code review. We want some people to take a look at it and also express their opinion regarding any improvements that can be done. Of course, if we're talking about code review, this should be a process which only affects the code itself. So this is not something that needs to be taken personally, but instead it's a learning process where we can see some other opinions which might help us achieve better code. And hence, this is a very good time to improve what we have written before committing the code forever. So this would be the earlier we change the code, the better it will be. So this would be like a very good time in the software process development where we can address this problem with the code. A third moment when we can change something in the code is after we have actually run it quite a few times and we have analyzed the performance of the code we wrote. Sometimes this performance cannot be easily observed maybe on our machine. Maybe it needs to go through a certain CI or CD pipeline, like Jenkins, for example. And maybe those are the moments where we can see that, okay, there is a problem with the code and we can do some improvements. So as I said, this is also a good time to address whatever we find. The idea is not to leave refactoring not done when we can actually do it. Anytime we do it, it's good. Ideally, it's sooner than later, because the sooner we have a properly working code, the sooner we can rely on it to test our features. The next question we should ask ourselves is, how did we get to the point where we need refactoring? Why are we in this situation? And there are some key factors for getting to the phase of refactoring. And the first one is that maybe no code reviews were performed. Sometimes code just ends up in a repository without anybody taking a look at that. Not every repository has the coding review process in place. In some cases, you might have projects where without code reviews, the code cannot be committed to the main branch or to any kind of branch. Some projects don't have that, and that's why code reviews might be skipped. When somebody is responsible to manually create a code review, they might just overlook that process. And so in this case, any code just, slips unnoticed into the repository, and it might end up causing problems. Another issue is that sometimes when we are writing the code, we are not considering coding best practices. We don't know about them and we didn't learn about them. So we're just writing whatever code we can write at the time. And we don't really care about learning these best practices. So that's not very good. And I always advise to learn about the programming language we're using and to read, what these good practices are in order to have maintainable code in our repositories. A more serious problem is when we know what the best practices are, but we decided to skip them. We simply decided to write the code without taking these into account, and then we just released the code, and now it's out there, running and causing issues. Why would we skip these best practices? Well, sometimes it's just that we really need to deliver fast, and sometimes we're working in sprints where we are told that we need to deliver by the end of the sprint this many story points, and so the pressure is on the testers to deliver those points without really spending all of the time they need to write the best version of the code. So this is a very dangerous practice, and I highly recommend not doing this. Whenever you feel that you're writing the code, you always need to consider that you're following best practices. Otherwise, the code is going to be really, really messy after a while, and you will see that it's going to come back and it's going to be a problem at one point in the project. Sometimes we tend to ignore the so-called minor things. One example that comes to my mind is typos. So we don't really spend that much time naming things properly. We don't care whether we have two letters that have been inversed. For example, we tried to write a certain word, but we didn't write two letters properly. We inverted them. In this case, let's say that somebody is trying to find that code based on the name that they suspect somebody has given to this code. Maybe it was a method that they were looking for. If we didn't properly spell the method, somebody who is looking for it might not find it. Therefore, somebody will start writing the exact same code again because they simply didn't find what they wanted to find in the first place. So in this case, such a minor thing that we've omitted, a typo, is causing an issue in the code, meaning that we have duplicate code which really shouldn't be there in the code at all. So as we're adding minor things that we're overlooking, more minor things and so on, we end up with way too many minor things, and at one point we will see that this is going to affect performance in the testing, and then we will need to start doing refactoring. And the later you start doing refactoring, the more difficult it is, because we need to address and change more code, and we need to make sure that we are not destroying anything with the changes we are currently doing. So as I said, sometimes we just need to write fast code instead of writing the proper code, and that is very, very dangerous for the health of the entire testing project. So what do we do about it? How do we make sure we don't end up in the same situation with having to refactor a lot of our code? We need to frequently run code analyzers. So if you have taken my IntelliJ course, you might know that I addressed a little bit the topic of the analyzer which we have integrated in IntelliJ. So we can run an automatic inspection from IntelliJ which will highlight a lot of issues in the project which we can fix. Either that we will go in and manually fix all of them and case by case take a look at them and analyze them and then apply the proper fix, or based on the features from IntelliJ, in some cases we might even perform an automatic update because it does suggest what changes need to be made, and we can apply them to all of the situations, all of the similar situations where these apply. We can also do some visual inspection, which I will show you in the next minutes, and we should just focus on the quality and make a commitment to keep quality in the project. We need to always consider coding good practices and to consider that we want to deliver high quality when it comes to our code. So it's going to be a continuous effort for us to have good code in our project, but it's worth it. The cleaner the project is, the healthier it is, the more easier it is for us to run the tests and to ultimately, deliver our products to the customers. And customers make money for the company, we get paid, and everybody's happy, and so on. So with these words of wisdom, so to say, I will just end the part with the slides. And now I will go into IntelliJ and we will start looking at some code. Now, I will show you some examples of certain actions that IntelliJ can help you with. These are not, I'm not writing an actual test, I'm just writing some code which will illustrate certain topics when it comes to testing. Please don't judge it, it's not going to be a real test, as I said, but you will pick up some information regarding how you can change the code you have written. And maybe some of the lines of code I will show you are already in your project, and you will realize that, okay, we can change these lines of code using IntelliJ right now. So what I will do is I will just start with creating a basic test. In my project, I'm using JUnit 5, but in your projects, you might be using TestNG. I will just start by creating the @test annotation, and I will just create a very basic first test method. As you've seen, I've already used one of the features from IntelliJ, namely the automatic import of the test annotation class. And the next thing which I'm going to do here is I will just write a few assert equals here. As I said, because I'm using JUnit 5, I need to say assertions.assert equals when I'm calling my assert equals methods. If you're using TestNG, this is going to be assert.assert equals for you. Now I need to import something when it comes to these assertions, so I will easily use the Alt-Enter shortcut, which will automatically import the assertions class for me. I don't need to do this myself. I'm just going to write that in the assert equals that 1 equals 2. This is just an example, so we know that this is not true for sure. I'm just going to duplicate this code twice using the Ctrl-D shortcut, because I want to have several assertions here. So I'm just going to say 3 equals 2 and 1 equals 1. I will show you why I'm writing this in a moment, but first I want to create a new test, and I'm just going to say @test, and similarly I'm going to create a second test method, and I'm just going to call this one second test. And here I also want to add an assertions.assert equals. And here I just want to compare 9 with 0, just for the purpose of example. Now, if we are looking at this code, we notice that assert equals is in italic. So the font is different from the assertions one. And that is because this method can be statically imported, which means we don't need to type assertions dot whenever we are using this if we are changing the import to something else. So our previous import for assertions was importing the org JUnit Jupyter API assertions class. However, we can easily change that, and we can easily remove all the assertions.text from our test class by hitting Alt-Enter on the word assertions, and selecting Add on-demand static import for this class. When we are doing this, two things will happen. The first one is that the assertions.text was removed from the entire class, and that is because a new import was generated for us, namely the import static methods from this class. So now our asserts are shorter, so we have less code in here. It's easier to read, and as you have seen, the change was made everywhere where we were using the assert equals method inside this class. So the automatic import helped in cleaning a lot of lines of code, and we didn't have to go and manually change all of these. Now, because we have made this change, the initial import which we made, the one with the assertions, is now obsolete. As you can see, it is grayed out. How can we remove any unused imports? Well, we have two options, either hitting Alt-Enter here or hitting Ctrl-Alt-L. Ctrl-Alt-L will actually reformat the entire code in this class, and it will nicely arrange the tabs and any spacing that we have between any commas and the text that comes after it and so on. But it also cleans up the import section. Okay, so we have created some assertions. Now let's say that in our test we need to write some lines, some strings as lines into a file. In order to do that, first we would need to create a new file. So I'm just going to go in the first test method and I'm going to say file, and I'm going to use Alt-Enter as a shortcut to auto-import the file class from java.io. And coming back to my file, I'm going to give this a name. I'm going to say new file equals new file. And here we would normally specify the path to the file. Now, because this is just a demo, I'm not going to actually type any path here, but I'm just going to put a string as is required by this method. Now, we might realize when we start writing code that the code that we are going to write right now is going to be used in several places or in several tests. For this purpose, it would be helpful for every code we write from here on to be put into a separate method which can be accessed by any test. How we can easily do that, how we can generate a method for the code we have here, is to just use the Ctrl-W shortcut several times until we have selected all the code we want to move into a method. And then we are going to use the Ctrl-Alt-M shortcut, which is going to create a method for us automatically. You can see that here we have the so-called private void extracted method, and extracted is just a name given by IntelliJ because it was an extracted method. But right now we can actually change the name of this method, and I'm just going to call it write to file. So what we have accomplished now is to automatically generate a method out of selected code. Of course, if we had more code that we wanted to add into the method, we should have selected that one and then used the Ctrl-Alt-M shortcut. Now, if we come back into this method, we might realize that, okay, new file is currently grayed out. So sometimes if you're looking in your tests, you might have variables which are grayed out. In case you have the declaration of the variable together with the assigned initialization, like I have here, you could choose to refactor this in two ways. The first thing you would do is hit Alt-Enter here, and you could say remove local variable. This means it's an unused variable, and you can remove it, but you can remove it in two ways. The first thing you could do from this screen is to remove it entirely. So if we choose to remove the variable, it will be gone entirely together with the assignation. So we will not have any more variable declaration and no assignation as we had initially. However, let's say that on the right-hand side, the assignation is something that actually needs to happen. So there is an action that happens there, but we don't really care about the result and we don't want to store the result of that action into a variable as we have here. In that case, what we can do is go back to new file, click Alt-Enter while we are while we have the cursor right on the name of the variable. Again, choose to remove the local variable, but this time we can choose to transform it. And here only the left-hand side disappeared. So what we had to the left of the equal sign together with the equal sign, and the right-hand side is still here. Because as we said, we want whatever is happening here to actually happen. We just don't care to store the result into a variable. This might be something you might have in your tests. Now I'm going to undo this action simply because I'm going to use this variable in the next steps, so I don't want to delete it. While I am still with the cursor on this variable, you can see on the left-hand side that we have a yellow bulb, a light bulb here. So the light bulb indicates that there is some improvement we can do here. So you either, with the cursor, go onto the variable and hit Alt-Enter, or you could just put the cursor on the variable and then open from the bulb the suggestion box, which is basically the same thing. So you will get the exact same suggestions, whatever works for you. As you see, of course, it shows us that we can remove the variable, but as I mentioned, I'm not going to do that. I want to actually use the variable for something. Now, what am I going to do with this file? I want to write something to this file. In order to do that, I'm going to use the so-called file utils method. And here we have the so-called write lines method. So this is very easy. Whenever you want to write something to a file, you can use this method. It's in the Apache Commons library. In order to write the lines, first we need to create them. So I'm going to create a new array of strings, because actually a list of strings, because I want to put each of these strings on a new line inside the file. So I'm just going to create a new list, and the list will be, as I said, of strings. Again, here I will need to import list, and I will do this by using Alt-Enter, and it will be automatically imported for me. I'm going to give this list a name, and I'm going to say lines to write. And then I'm just going to create an array as list, and I'm just going to say text1, text2, and text3. Okay, so now we have the file to which we want to write, and now we also have each of the lines we want to have in the file. So each of these texts will be created on a new line inside the file. Coming back to the write lines method here, I will say that I want to write, and as you can see, the signature of this method, to the new file, the lines to write items. And at this point, we have the method that will write all the information to the correct file. But as you can see, our method write lines is underlined in red. And when we click on it, now we see a red bulb. What does this mean? Oh, there's something we need to address when it comes to this method. Namely, we need to either add an exception to the method signature, so to the write to file method, or we need to surround this code with try catch. Why is that? Simply because the write lines method itself throws an exception. So whenever we are calling this method, the method which calls this method also needs to throw this exception, or it needs to use a try catch to deal with the fact that this method will throw an exception. In our case, we don't want to do any try catch. We just want to in turn throw the exception. So now we did a refactoring of our initial method signature because we are now throwing an exception. If we are looking at our test, we can see that this test also is in red right now, because we are using a method that throws an exception, we need to throw it here too. So I'm going to use again the Alt-Enter shortcut, and again we will automatically add the throws IO exception part to our test method signature. So that's good. We have automatically added the exception thrown by this method. But sometimes we might be using some other code which is throwing a different exception. I'm just going to use this thread sleep here. Of course, don't use thread sleep in your code. I just want to show you an example here. When I'm using Alt-Enter here, there is a different exception we would need to throw. So as you've seen, we already have two exceptions we are throwing here. So they start to stack up. If we are going to use many more methods in our test, we might end up with a lot of them. So we can do a refactoring here, and we can use the Alt-Enter shortcut when we are on the interrupted exception, for example, with the cursor. And here we can just say replace with throws exception. And this means that instead of the two exceptions we had initially, we now have the generic one, exception, which is like the mother of all exceptions. So here we don't need to enumerate all of those exceptions we need to throw, because writing all of that code is just going to be pollution for our testing. So we are just going to throw the general exception, and so whenever we call any other methods that might throw a different exception from those two that we initially had, those are covered by the generic exception. Coming back to the test method, we might see here that, of course, because we changed which exception we are throwing, this is causing an error here, so we need to update the exception. But let's say for demo purposes that we decided not to use this write to file method anymore. Now we are left with a throws exception, which is not used anymore, right? So it's grayed out. Instead of us having to come and manually delete it from this place, we can just come to it, click with the cursor, use Alt-Enter, and just select the Remove IO Exception from Throws List option, and this will be cleaned up for us automatically. So we won't need to backspace, 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 and so on. But for the purpose of our test, we do want to use the write to file method. And so here I'm going to again use Alt-Enter, and I will choose to add the exception to the method signature. So good. For now, we have a working method that we're calling from a test. Now let's say we are coming back to the second test method, and that here also we want to write to file. So we also want to call this method. I'm just going to call it, and then again, using Alt-Enter, I will throw the exception. Now, let's come back to the actual method. So let's say that from each test from where we want to call this method, from where we want to write to a certain file, we want to specify the path to a different file. So we don't want the file to be the file location to be the same every time. We want to pass it through a test. In our method, we have hard-coded this path. So what can we do in order to make it a parameter? It's very easy. We're just going to select it, and we're going to use the Ctrl-Alt-P shortcut. This means we're going to do a refactoring for extracting a parameter from that value. And we're just going to say to hit enter when we have these screens here. And what happens is that the parameter was introduced, so the signature of the method was changed to have a string parameter here. The name was kept because it represents, the text that we had here, but of course you could rename the parameter to something that you want. And in the tests, we have provided automatically the value of the path to the file. So we didn't have to manually go to every place from where we are calling this method and provide the path we are interested in. It was automatically replaced for us by IntelliJ once we extracted the value of what we had here. Because when we introduced the parameter, we had a certain value, and that value was propagated into all of the tests from where we were calling that method. And of course, if we want to change the path to the file in any of the tests, we can just go to that test and we can just change it to something else that we need. In my case, I'm just going to say path to the file 2. Okay, what if we need some extra refactoring? So let's say we have taken a look at the test and we realize that additionally, we want to be able to pass in a new parameter from a test, a second parameter, and we want that that second parameter to be a string, which represents the last line we want to add to a file. So in my case, I went and changed the first test method, and I just added an extra parameter here directly to where I am calling that method. Of course, this becomes underlined with red because we do not yet have a method with this signature. So we have a write to file method, but it only takes one parameter, which is a string one. So now we could refactor this, and we have several options. The first one is one of them is to create a new method. And if we are choosing this option, automatically we will get a new method created for us, which has the same signature, the same return type as our initial write to file method, just at this time, instead of one parameter, it has two parameters being passed to the method. But in our example, we don't want to do this. We don't want to create a brand new method. So I'm going to use the Ctrl+Z shortcut here. And instead, I will just go back, use Alt-Enter, and add a second parameter to our initial method. And this will be of type string. So when I do this, I get the following screen. And in this screen, we can see that we will change the signature of our initial method, and it will have a second parameter here. If we click inside the window here on the parameter, we will see the type for it, we will see the name for it, and a default value. So this is the value which will be passed into the method, and we can just change this name to, let's say, fourth text, just so we have a different name for this parameter. So if I'm going to refactor this, we are going to see a brand new version of the write to file method. Namely, here we introduced a second parameter. Of course, at this time, this is not yet used inside the method. If I scroll lower, we will see that in the second test, the value text4 was also automatically added because this was the default value which we specified when we did the refactoring. Let's say we can just change this to whatever we want. So I'm just going to say text44 here. Since we introduced a new parameter, we should use it. So we should do something with it, right? We didn't introduce it for nothing. So I'm just going to say that this is the fourth text that we want to write to our initial file. So this is how we updated the method, the signature of the method, and also any test that was using this method. We added some default values to be passed to this method from each of the tests. Now, looking at the lines which we want to write here, let's say we want to actually introduce or to extract a variable out of this text3, and we want this variable to be local to this method. In order to extract the variable, we will just say Ctrl+Alt+V, and here we have the option, for example, to declare it final, but we don't want that. Let's say we will need this variable somewhere else inside the method, so we will need to assign it different values throughout the method. I just want to change the text, the name for this variable. I'm going to say third text, and I'm going to hit enter, and now the refactoring is complete. We have extracted the third element from this list into a variable. Let's say I'm going to do a system out for it. And of course, as I said, you could use it in so many other ways inside your code, but for this example, I'm just going to do a system out. And let's say we have at one point decided that we actually want to change the name for this. So in order to change the name, we will just use the Shift F6 shortcut. And here we have two options: to rename only the code occurrences, or to also rename all of the occurrences. This means that if I highlight the first option, you can see the places where this is going to be changed. So only where the variable is used will the new value be displayed. If I'm choosing all occurrences, you can see that in the comment here, actually in the system out, my system out also said that the name of the variable is this. So if I change it, I can change the system out also if I'm changing if I'm choosing this option of renaming all occurrences. So let's say that we're going with that one, and I'm just going to say that the new name should be the third text. So now you can see that the change has been applied both in the occurrences of the variable, but also of the name of the variable. Looking back again at the lines we are trying to add to our files, let's say that we want the second item here to actually be a field. So we want this to be declared on a class level instead of inside the method. So we're going to use the Ctrl+Alt+F shortcut to extract a field out of this value. And here we have the option to initialize it either in a current method or in the field declaration. Now, because it's a field, I want to do it in the field declaration. So I'm going to choose that option. I'm going to say enter. And now my field was declared in the section of where the fields are declared, so on the top of the class, and it also became final because I've already assigned a value to it. Of course, if I want to change it anywhere inside the test class, I could just delete the final part from here. Let's say that what we are doing next is that we have decided we don't want to use the fourth text anymore. So we don't need this anymore. We decided that in the test, we are not going to call the method with this parameter. So we have deleted it from where it is used inside the method. And now we're just going to go and hit Alt-Enter here in the signature of the method. And then we can choose to safely delete this parameter. And once we do that, it does not only get removed from the signature of this method, but also from all of the usages. So you have seen that here we are not passing this parameter anymore. It's gone, it's done with. Okay, so let's say that we are done with the writing to the file, and let's say that we want to create a brand new method, and we want it to be a method which returns an int, and let's just say that we want to calculate the sum of some elements of a list. And for the sake of the purpose, I'm just going to say that I want to store into a variable, which I'm initializing with 0, which I'm calling sum, the result of adding all of the elements in a list. The list will be a list of integer numbers, and we're going to call the list numbers to add, and the list will consist of, let's say, 1, 2, 3, 4, and 5, just for the sake of purpose, for the sake of example. How would we do this? Well, we would write a classic for, which is for int y starting from 0, where I is less than the size of this list, and then we're just incrementing I, and let's just say that we are adding to sum every element from that list by calling numbers to add dot get I. So we are iterating through this list and we're adding all of these elements to the sum. And of course, at the end, we want to return the sum. Now, if we are looking at the sum, maybe we realize that this 4 is not necessarily what we want. So maybe we want to refactor it. If I go to my light bulb here, I can choose the option to replace it with an enhanced 4. So what does this mean? The code that I just wrote will be changed, and it will not use the I parameter here anymore. So we're not using this classic old approach. We are going to go with the enhanced 4. So we're going to iterate through the list, and for every integer we find in the list, we are just going to add it to the sum. Okay, that's good. It looks better, but still there might be some improvement to be made. And yes, there is, because if we're clicking on this 4, we see that we have another option in the light bulb, and this option is, for example, to replace it with sum. What does this do? Well, I will show you the magic here. It simply replaces the entire 4 with a different way of calculating the sum. So it uses some methods from strings, and strings are something which were introduced in Java in a later version, so I think in version 8. But this is a way of refactoring your code to make it, let's say, more modern and not to use any for constructs. This is basically writing the same code shorter. Some further improvements we might have. We have seen that here we have declared a variable and then we are just giving it a value here. The light bulb says that we can join the declaration and the assignment. So we can just put everything into one line because this is the only place where we're actually using this variable. And because this is the only place where we are using the variable in the entire method, we can further improve the code by going back to our light bulb and selecting inline variable. This means we are not using the sum variable anymore. We are just directly returning a value. and the value is calculated inside this return. So here the refactoring was step by step, where from having a variable and a for, we had a different version of a for, and then we actually reduced that to better code. And now, instead of the 5 lines of code which we had initially, we will just have this one, which will in turn do exactly what we needed it to do. Let's say we also have an in our method an if. Let's say we have if let's say 1 less than 0, do a system out, and else do something else. Let's do another system out. Again, this is just an example, so I don't expect you to write such code. But what I'm trying to point out here is that if we're going to the if, we might get an improvement. Because of the fact that we have this if, where we are just comparing a certain value to something, and in case the value is different, we are doing an else, we could actually use the shorthand if instead of the one we have here, and we can just automatically change this, and we could just use the simplified version, namely we can automatically replace the if with this code. So the simplified version is the one which uses a question mark and the semicolon here. This is because we were doing a system out, but if we are assigning a value, let's see what that looks like. So let's say that we have int param, no, actually int, okay, I'm going to call it j. And let's say we have an if where if 1 less than 0, we are going to say that j will be 0, else let's just say that j will be -1, just for the sake of the example. We can make this code way shorter by using this shorthand version of the if we go here and choose to replace this code with the simplified if. So now instead of all of those lines of code, we are doing the exact same thing, but we are using the shorthand for. And these are basically the shortcuts I wanted to show you today, and how to do the refactoring. One thing to mention is that when we are writing the code, on the right hand side, we might see all these yellow areas, so yellow, let's say, rectangles. These mean these are places where we can do some improvements or some refactoring. We can also see the warnings here on top on the right. And if we're looking into the warnings section, we can see what code can be updated in our class. For example, this field we have extracted here, we are not using it currently anywhere else, so we could just convert it to a variable. In order to do that, we could just right-click on this entry here, choose to show quick fixes, and then just select the option which is more suitable for us. And in this case, it was to just move the field declaration and transform it into a variable declaration. So now it's inside the method. Additionally, for example, the variable j is never used, so we could just show the quick fixes and we could just remove this local variable. It was just some code that we wrote, which we are not ever using. So whenever we are writing our test, we can look at these guidelines here, and if we see any warnings, that's something we need to address and fix. And if instead we would see the green checkbox, then everything would be fine. So the code would be considered proper and we wouldn't need to do any more updates inside this code. So I hope these were some useful tips for you on how to change some of your code. Keep in mind that whenever you see yellow, there is something you can change. And if you ever see, if you're scrolling or moving through the code and you see the yellow bulb, or even the red one, that means you might find some interesting suggestions to update your code. So this is everything from my side. So I think we are open for questions.
Great. So I'm just reminding everyone, if you have questions, put them in the question panel. While you're writing them, I'll just remind you that the recording to this webinar will be emailed to you by end of day Monday. So waiting for questions to come in. In the meanwhile, while we're waiting, Corina, do you have any questions that you're usually getting about IntelliJ that you want to bring up and answer, or anything else that you want to say?
Yeah, so it's it's quite a used IDE, and it has a lot of shortcuts which people can use. There is also on their website a list of all the available shortcuts you can use, and by applying them in your day-to-day work, you can easily refactor your work, and you can shorten the time of writing the code, because you can also auto-generate all kinds of things. You can change what you have written and so on. So it's very, very useful for creating your code, but also it's useful for pushing the code to a repository, keeping it in sync with the repository. So yeah, I think it's very good for us to use. So
Great. So we have some questions coming in. How can you create a template if you write a method a certain way a lot?
I'm not exactly sure how you can. So there are some templates, but they're more like shortcuts. So for example, for system out, you have, if you type, for example, south something here, it, for example, the main method has some sort of shortcut. I'm not sure which is the, yeah. So main tab generates this definition for the method. I think if we're going to settings and we're looking for something like templates or live templates, that's where we can find something like this. So I'm not exactly sure, but you should look for something like live templates. It might be here somewhere, but I'll take a look and I will let you know on Twitter after this. They are called live templates, so you can actually generate something like that. Yes.
Next question, where can we find the list of shortcuts?
Yes, if you go to the website of IntelliJ, you just need to look for keymap. So keymap references, I think, is the name of the file. So just Google that up and it will bring, it has a very nice format. So you can see all of the shortcuts on kind of a printable PDF file. And they have the shortcuts both for Mac users and for non-Mac users, so that you can use all of the shortcuts, even if you have a special keyboard.
Which languages does IntelliJ work with? Is there an IntelliJ plugin for Visual Studio Code?
I'm not exactly sure. I think this is best to be checked on their website. I know that, for example, for Python, they have a different tool that they're using. So instead of IntelliJ, they have the so-called, sorry, not for Python. Yeah, for Python, I think they have PyCharm. And for PHP, they have PHP Store. So there might be a different program for other languages. I'm not sure about Visual Studio. But if you look at on their website, you could check it out. Basically, all of these tools have common cores, so shortcuts and stuff like that are common in all of these, and the interfaces are rather similar. It's just that they're supporting different languages with their specifics.
In pursuit of reducing the code, we sometimes tend to make it complex from a readability point of view. So where do you suggest to stop refactoring?
Yes, I think once we are not able to read the code anymore, then we should not refactor it anymore. The purpose of refactoring is always to get a better version of the code. But if better means that nobody understands what the code is doing, that's not right. If we don't know what it's doing, how can we measure that it's doing the right thing? So I had this situation once where we had a developer looking at a properly working code, and he decided to change that code to something else which wasn't necessarily better. So the performance was exactly the same. It's just that he was using something more sophisticated, which was more to his liking. but none of us testers really could read the code. We couldn't really understand what the code was doing. So in this case, we decided not to go with that version because it really didn't help us with anything. It wasn't improving anything, and we didn't know what we were looking at. So the previous version was accepted, and that was the one which was used from then on. So it's very important for you to know what you're looking at. The code you are writing, okay, it needs to be efficient, but if nobody knows what it is, yeah, don't do it.
Next question, how to put a comment above the method automatically with information like input variables and output variables and author, for example?
If we have this method here, so we have a write to file method. I think you still see the screen. So we can auto-generate the Java doc by typing /** and hitting enter. And here it generates, it looks at the signature and it generates the entry for, for the signature because it looks at the parameters and the exception. And this is where you can type, this is what the method does. So here you can add some extra information. If we're looking at the class level, let's see, what can we add here? Here we don't really have anything like author, but I think if you type @ these things will appear. So you will get hints regarding what you can write on every level. So on the class level, on the method level, and so on.
We are out of time, but we'll take just two quick last questions. Is Code Analyzer a plugin in IntelliJ, or does it come as a default? How can we run the Code Analyzer?
Great question. It comes by default, and you can access it by right-clicking inside a class, for example, or even on the project level, you can go and right-click and then go to Analyze, Inspect Code. So Analyze, Inspect Code, and this is where the analyzer will come up, and it will ask you, like here we're on the project level, it will ask you where you want to look for bad code. In the whole project, only in uncommitted files, which is a very useful thing, in a certain directory, and so on. If we just go to analyze and inspect code from a method, it will just look, from a file, it will just by default look into that file. And when we are hitting OK, it will generate the results, and we can see them here in the lower side of the screen. So this is going to be the inspection results panel, which we can look at. And from here, of course, we can also apply automatically the changes. So if we have unused declarations, we can use save delete from here, and it will automatically delete the unused imports which we had right now.
And one last question. I tried to replace the loop as you explained and could not find it in IntelliJ. Where is it?
So you did the loop, the for, and you need to first of all, you need to use the latest version. So I'm working with the latest version here. You might have a version which doesn't support this. In some cases, you might have inspections turned off or something like that. So you will need to go to settings and look for that. Otherwise, these things come up easily when you are just typing and then Alt Enter or click on the word for. And here is where the light bulb would appear, and here is where the suggestion needs to appear.
Great. So unfortunately, that's all the time we have for today. I'm going to ask Corina to revert back to her cover slide so you can see all of her information. I want to thank everyone that joined us for this live session, and of course, thank our speaker, Corina Pip. Before I let Corina say her goodbyes, I want to remind you that the link to the recording of the session will be emailed to you by end of day Monday, and I hope to see you all at our next event.
Thank you very much for joining. I hope this was useful for you. Don't forget to take a look at my course on IntelliJ on the Test Automation University platform. It's free and it's very comprehensive. There's a lot of information there. And stay tuned, as there will be a new course coming from me on the same platform very, very soon. Thank you very much. Have a great day and happy testing.